Alright, in this video we're going to talk about Unit 11, Objective 2, and this time we're going to talk about the limit comparison test. Limit comparison test is very similar to the comparison test that we just had, except we're going to use this when the comparison test doesn't work. So we'll start there. So use when the comparison test does not work. And you can actually use this in place of the comparison test, but the comparison test is a little bit quicker when you're allowed to use it. So what I mean by when the limit comparison test doesn't work, that's when we cannot find a b of n that's greater than a of n easily. So sometimes you're going to easily be able to find a b of n that's going to be greater than a of n all the time, but sometimes you're not going to. So here's what your limit comparison test says. So again, we're going to suppose we have two series. And again, we're going to call them a of n, which we'll say has to be greater than 0, and b of n, which, oops, make that the sum, not just b of n. And the sum of b of n, and again, let's make sure that's greater than 0. And that's going to be for all n. What we're going to want to do is define a limit as n goes to infinity of a of n over b of n, and we're going to set that equal to c, some number c. Now, parenthetically, I'm also going to say that this will work, and we'll talk about when we want to do which one in a minute. But we could say the limit of b of n over a of n equals c. That will work as well. So if c is in between 0 and infinity, so it's a finite positive number, then both a of n and b of n will converge or diverge. So if one converges, the other converges. If one diverges, the other diverges. So they're both going to converge or they're both going to diverge. So this is actually a little bit more handy than the comparison test, in so much as the comparison test only told us that if A diverges, then B diverges, and that really didn't help us much. So let's look at a question. You'll kind of see how we can't easily find a b of n that's going to be greater than a of n, and we'll talk about which of these limits we actually want to use. So let's just say, will the sum from n equal 0 to infinity of 1 over 3 to the n minus n converge? Now, in the last video, we looked at 1 over 3 to the n plus n. And we were able to say that, again, we'll say this time that a of n equals 1 over 3 to the n minus n. And just like the comparison test, we want our b of n to be something that looks like a geometric series or a p-series. So we're still going to say b of n is 1 over 3 to the n. The problem is, since we are now in a of n subtracting the n in our denominator, that makes our denominator smaller, which makes our value bigger. So in this case, a of n is actually bigger than b of n, so we can't use our comparison test. But we can use our limit comparison test, because these are both going to be positive values as n goes from 0 to infinity, and we don't, like I said, don't care about which one is bigger than the other. So we have two options. We could say the limit as n goes to infinity of a of n over b of n, or we can say the limit as n goes to infinity of b of n over a of n. Remember, it's not really going to matter which one we choose. That they both work, but one's going to be a better option. So if we think a of n divided by b of n, I have a of n is this. And if I divide by b of n, I'm dividing by a fraction, so I'm multiplying by its reciprocal. So we're going to get 3 to the n over 1, which is going to give us the limit as n goes to infinity of 3 to the n over 3 to the n minus n. The other option is going with b of n over a of n, and similarly, we're going to end up at 3 to the n minus n over 3 to the n. Now, on the surface, one of them doesn't really look better than the other, but when you think about it, we can simplify the second one a little bit better, the one where we use b of n over a of n, because we have an STD. This is going to allow us to rewrite our limit as 3 to the n over 3 to the n minus n over 3 to the n, which is going to be the limit as n goes to infinity of 1 minus n over 3 to the n. So now we're to the point where we can take our limit, so we want to try first plugging in infinity, see what happens. We're going to get infinity over infinity. In this case, we would normally take a derivative. We'd use L'Hopital's rule, except we don't know how to differentiate 3 to the n, so we kind of have to think about what's going to happen. They're both going to infinity, but our denominator is growing exponentially. So it's going to get to infinity a lot faster than the linear function just n. So our denominator grows faster than our numerator. So that's going to mean our denominator is going to hit infinity before our numerator. So we're going to have some number divided by infinity, which is going to be 0. So this limit is just 1. We have 1 minus 0 is 1. So since 1 is a finite positive number, we know both a of n and b of n are going to either converge or diverge. So we'll put a little note there. So we'll say, because of that, both a of n and b of n will converge or diverge. So now we just have to decide which one do we want to look at and which one do we want to find out if it converges. Well, obviously we can't look at a of n because that's the whole question, so we need to look at b of n. Does b of n converge or does b of n diverge? Well, we know that, again, b of n can be rewritten like this. So we can say b of n converges because 1/3 is less than 1, so a of n also converges. So comparison test, if you can't use, limit comparison test, if you can't use your comparison test, we want to do either a of n over b of n, take the limit as n goes to infinity, or b of n over a of n as n goes to infinity. We want to try to get an STD so we can cancel some things out, and we might have to use L'Hopital's rule when we take our limits. So that's going to do it in this video. We'll see you in the next one.